This video has been made to present the process of assembly, erection, bolting and launching of open web girder of size 61 meter or 200 feet over Sharda Canal in connection with Rosa Sitapur city dubbing of work. The Sharda Canal is the longest canal in Uttar Pradesh. Along with its several branches, it forms a network of canals. At bridge site, the width of canal is 47 meter and angle of skew is 41 degree. The discharge of water is 70 cubic and flow velocity is 1.22 meter per second. Getting closer of canal is too difficult. So it has been decided to launch the girder with end launching scheme, which is most challenging task. The prefabricated parts of the girder components are transported from bridge workshop Jalandhar Cant to the site of the bridge. Before starting assembly, metallizing, which is an anti-corrosion treatment, is to be done on members. For that, the surface of steel shall be free from oil, grease, bituminous materials or other foreign matter and shall provide an adequate key for the sprayed metallic coating. This is achieved by sand blasting. The sand blasting is done at site to achieve surface roughness as per ASTM level of SA 2.5. Final cleaning is done by abrasives, that is chilled iron grit G24 as defined in BS 2451 or washed salt-free angular silica sand of mesh size 12 to 30 with a minimum of 40% retained on a 20 mesh screen. Air pressures during blasting should not be less than 2.109 kg per square centimeter. Nozzle position should be at right angles to and approximately 22.5 centimeter from the surface. Nozzle dia should not exceed 12 mm. The sprayed coating shall be applied as soon as possible after surface preparation. The wire method shall be used for this purpose. The diameter of the wire should be 3 mm to 5 mm. The composition of the aluminium to be sprayed shall be preferably in accordance with BS 1475. Metallizing is done with 99.5% pure aluminium wire conforming to IS 739. Clean dry air pressure should not be less than 4.218 kg per square centimeter. The minimum thickness of metal coating applied shall be 115 microns and average thickness 150 microns. The specified thickness of coating shall be applied in multiple layers, not less than 2. The surface after spraying shall be free from uncoated parts or lumps of loosely spattered metal. At least one layer of the coating must be applied within 4 hours of blasting and the surface must be finished to the specified thickness within 8 hours of blasting. The metal coating shall be checked for thickness by an approved magnetic thickness measuring gauge. The calibration of the gauge should be checked against a standard of similar thickness within an accuracy of 10%. After applying aluminium coating, coat of wash primer conforming to IS 5666 is applied. After that, zinc chromate primer conforming to IS 104 is applied. In the last, 2 coats of aluminium paint conforming to IS 2339 is applied. Each layer is applied with approved quality of paint to maintain color, viscosity, consistency and scratch hardness. In parallel of this, 123 meter long auxiliary track was prepared for rolling of structure. For that, 1.8 meter wide lean concrete in whole 123 meter length was done at both side and for firm base. Over that, 1.50 meter M15 concrete was done in whole length excluding the 10 meter area from approach. In the 10 meter area from approach, reinforced concrete was provided to avoid the settlement under excessive load. Ponding of water done on the surface for curing of concrete. After 14 days, wooden sleepers 1220 mm long, 250 mm wide and 150 mm thick are laid at the distance of 500 mm center to center. These wooden sleepers are encased in concrete. After fixing the wooden sleepers, double rails of 60 kg are laid over them and fixed with dog spikes. After completion of auxiliary track, metallized girder components are assembled on it by putting CC cribs on main joints and are joined together by using minimum 60% filling of holes with bolts and drifts. During assembly, the individual girder parts were erected with suitable set of stays or lateral restraints so that these did not topple over. The erection was done systematically in proper sequence. The members were handled from proper location for lifting or assembly so that these do not get damaged. During erection, the match markings were matched so that the holes matched and the members seated properly adjoining or over other members. Drifts or turned bolts were inserted in the holes to ensure that the members matched ones do not slip or move out of place again. First, the bottom members like bottom cord cross girder, bottom cross bracing, stringer girder are joined using temporary bolts. Then web members like vertical and diagonal members are erected. Then top members like top cord from center to end. Then sway girder, top cross bracings are connected. At last, end rakers and porter girders are joined. The partially assembled girder is put on camber jacks in such a way that the designated camber of 70.5 mm is available. As assembly proceeds, the bolts and drifts from previously joined section are removed and replaced by permanent HSFG bolts. 8.8 property class HSFG bolts of RDSO approved firm are used for connections. HSFG bolts are provided with DTI washer on head side and plain washer at nut side. All field joints are fixed with M22 dia HSFG bolts. The tightening of bolts are done in two stages. In the first stage of tightening, all bolts in the joint shall be tightened in snug tight condition. Nut is tightened using an ordinary wrench by an average worker, applying maximum force on the wrench. This stage is required to bring the plies in close contact. After first stage of tightening, the joint shall be checked to see if the plies are in close contact and the clearances are not exceeded. In the second stage of tightening, torque wrench is used to tighten the bolts until the indications on the DTI indicate hole tightening. The direct tension indicators are special type of washers with indentations which get pressed when tension is applied. The pressing of indentations to required level indicates that the required tension has been applied in the bolts. Resemblance of DTIs with washers is identical. In fact, these are precision-engineered mechanical load cell, which is the most reliable method of checking HSFG bolt tensioning. DTIs have multiple projections, between which the feeler gauge is to be inserted to check if the bolt has been sufficiently tightened or not. After second stage tightening, 0.40 mm thick feeler gauge shall be used to check 100% of the bolts for proper tightening. The feeler gauge shall be used to determine if the bolt has been sufficiently tightened or not. Calibrated torque wrench is also used to check whether the bolts are tightened on proper designated torque or not. If loose bolts are found, the same was marked by a round circle all around and shall be replaced expeditiously. HSFG bolts are one-time use item and retightening of these bolts is not allowed. A fully tensioned bolt opened out for any reason whatsoever, rejected and removal from the site of work. Along with the bolt, the nut, washer and DTI used on that bolt also rejected and removed from the site of work. All the bolts must have at least 2 threads out from the nut and all the bolts have equal threads outside the nut. On the approach of each abutment, temporary arrangement was done to lay the auxiliary track. CC cribs staging was provided to minimize the unsupported length. Over CC cribs, joists of ISM B400 are provided transverse to the track and joists of ISM B200 are provided along the track. The same arrangement was prepared on A2 abutment which will receive the girder. Callender Hamilton length of 56 meter was used as a launching nose to facilitate the end launching. The assembly of Callender Hamilton nose was done at abutment A1 side, adjacent to the main girder. The assembly was done with the help of standard angle, bottom main gusset, cross bearer, double gusset, top main gusset, top bracing channel and wind bracing angle, etc. These are connected with HTS bolts and washers. As the assembly of Callender Hamilton nose completed, it is connected to the main girder with the help of link members containing channels, angles and gusset plates. All the bolts of link member and CH nose should be properly tight to minimize the deflection. As the bolts are fully tightened, the CC cribs are pulled out below the girder and trolleys are inserted. To pull out the heavy weight of 355 metric ton, two electric winches of 10 metric ton capacity in front side and two winches at rear side are used to pull the girder. For that, 2 meter deep reinforced concrete foundation were casted. Over that, winches are fixed with holding down bolts. After fixing and testing of all pulling arrangement, launching of girder started. After successful launching of girder, Callender Hamilton nose is dismantled by removing members one by one and link members are also detached. Now the girder is lowered on the rocker roller bearings with the help of jacks. Then the track is laid over the girder by using channel sleepers, guardrail and checkered plate and make functional for running of trains. This bridge facilitates the doubling of Rosa Sitapur city section of Moradabad division.